elbow articulations include you have the trochlea and the trochlear notch. Trochlea. Trochlea is of the humerus, and that articulates with the trochlear notch. That's of the ulnar bone. That's the main articulation. Okay. I'll point these out when there's system on the board, but there's two others. You have the capitulum of the humerus. That articulates with pretty much the head of radius. For a second articulation. Then you have a third articulation. The head of radius articulates with the ulna. In particular, there's a little notch in the ulna bone. They actually call it the radial notch of the ulna. For three articulations, basically this last one they call the proximal radial ulnar joint, this third one. It's part of the elbow, but the joint has its own name. Proximal radial ulnar joint. But put it all under elbow, all right there. Let me show it to you. So I'll just select the bones. I'll just explode them. Put them back together. Let me zoom in there. First one, trochlear notch. Okay, so here's the trochlea, and it fits into the notch of this bone. If I rotate it to the side, you can kind of see how the trochlea fits in something called the trochlear notch. First articulation, this round thing here, that's the trochlea. It fits in this notch, the trochlear notch, and this bone is the ulna. That's the first one. Second one, turn it to the other side. The second one, that's the capitulum, that round ball, and that's the head of the radius. Third one, head of radius, articulates in the little notch there of the ulna. So find all these things on the bones in the lap and try to put them together. That's the elbow. And I want to give you one ligament to know for the elbow. There's more than one, but one I want you to know, because I'll talk about it in another lecture, is the ulnar collateral ligament. So in your two forearm bones, the inside bone is the ulnar bone. So anything that's named ulnar, look for it on the medial aspect. Go back to the full body mode. I'll put it in the connective tissue there. That ligament right there, oh, it's hard to see. Let me get that off. There we go. Highlight it in green. Is the ulnar collateral ligament. I'm pulling out, see that little green spot there. Collateral ligaments are on the sides. of joints, either on this side or on this side. I want you to know this, the one on the medial aspect, that's the ulnar collateral ligament. It's connecting from the medial epicondyle to proximal ulna on the medial aspect. It's prone to rupture, strain. UCL for short. Basically, it helps stabilize the elbow joint. It attaches from medial epicondyle, that's of the humerus, and goes to proximal ulna. So I want to move away from the elbow joint and talk about the ulna bone itself. So in the anatomical position, with your palms facing forward, the ulna bone is the inside bone of the forearm on either side. So we're going to look at the one on the right. And the first thing on your study list is a structure called the olecranon. It's highlighted in green there. It's a posterior view. It's a big process highlighted in green. Usually you have a head that's proximal, but not for this bone. The olecranon is the bony part of your elbow. So it's a big process. It's the proximal part. It's pretty much where the triceps brachii inserts. It attaches there. It's proximal, triceps, brachii inserts. This is the posterior view. If you rotate it around to the front, zoom in a little bit, that lip that's sticking up, well, it's everything that's highlighted in green. Call that the coronoid process. The coronoid process is, well, what I had said in the last lecture is when you flex the elbow, that process fits in the olecranon fossa. I'm sorry. Fits in the coronoid fossa. Is that what I said? Sometimes I don't remember what I said a second ago. The whole point of the fossa and the process, they have the same name, right? Because they fit into each other. The process fits in the fossa of the same name during flexion, elbow flexion. Elbow. And I did show that to you the last time in animation. I do remember that. Well, anyways, the olecranon and the coronoid fossa, and in between, this bone looks like a monkey wrench. So that notch is called the trochlear notch, highlighted in green. Trochlear notch. And that fits the trochlea. See if you're awake this morning. What bone is the trochlea on? You just wrote down. The trochlea is a structure on the humerus. It's one of those condyles. Trochlear notch fits trochlea. Now, basically, that articulation, it makes the elbow what we call a hinge joint. I'll write that. Elbow is considered a hinge joint. A joint that is called a hinge can have movement pretty much in one plane. So if I'm in the anatomical position, I'm flexing my forearms, what plane is this? That runs front to back. The sagittal plane. Yeah. Okay, well anyways, hinge joint, trochlear notch. Let's move on. Oh, okay. Then rotate it, that's on the inside. Okay, that little green spot, it's a perfect little notch. It's kind of hard to tell on the app. You got to play with the bones in the lab to see. That receives the head of the radius. So that's the thing I wrote earlier for the proximal radioulnar joint. That is the radial notch of the ulna. What I had said previously is that forms the proximal radioulnar joint, okay, because it receives radial head. I'll just write that. Receives head of radius. How about that? Head of radius. Let's go distal. I'm going to go back to landmarks. The head of the ulna, oddly enough, is distal. So the head of the ulna, here's the whole bone. The bone is kind of thicker proximally, and as you go from proximal to distal, it gets more slender. And then you get all the way down here, and then you have the head, which is distal, which is unusual. Usually it goes head first, then neck, then something else. But for this bone, the head is distal. Go down there. Of ulna distal. And there's a little nub right next to it. I'm going to zoom in and rotate just a little bit. It's called the Styloid Process. What's highlighted in green, that little nub. There's another styloid process on the radius, but they basically help, well, they're attachment points for ligaments. They help stabilize the wrist joint, as we'll see. You just kind of know that styloid process of ulna. They're also prone to fracture. Those little parts that stick out tend to break off. Okay. Done with ulna. Let's do its partner bone in the forearm, the radius, highlighted in green. In the anatomical position, you tell me, is that medial or lateral? In the anatomical position, it would be the lateral bone of the forearm. So, the radius bone, as we said, articulates with the capitulum of the ulnar joint. The surface features, the radius bone actually has its head proximal, like we're used to seeing. Okay, I'm going to highlight that knob end as the head. This app, it labels everything the head. That's the articular circumference of the head of radius. That's the head of radius, and it even labels that top blue part, now green, the articular facet of the head of radius. Basically, the whole knob end is the head of the radius. Okay. Usually, when I tag it in a lab practical, I tag that knobby-looking end, described as the knob end of a baseball bat. It's very important that it's round because the radius bone radiates, and it's this head of the radius. It radiates to allow for pronation supination. So the first thing I'll write for head of radius is that it's proximal, not distal like the ulnar. It's proximal and it radiates in that radial notch. Quote unquote, radiates, hence the name of the bone, in radial notch, that's of the ulna. And when it radiates, the movement is called pronation supination. Of the forearm. Okay. Well, let's remember that the forearm is the region between elbow and wrist. Students always confuse arm and forearm. Just keep that straight. Because remember, in everyday language, when someone says your arm, they refer to the whole thing, right? But in anatomy, it's only, that's the arm, and this is the forearm. And so we're talking about forearm movement here. Let me show you pronation supination in case you forgot. Maybe I never taught it, I don't know. Well, here you go. There's a muscle called supinator, so we'll learn it later, but it'll show us this movement I'm talking about. So I'm gonna pull back. Hold on. Here we go. I'm gonna pull back so you can see the full forearm in view there. Supination, okay, when you go turn palm face down, and then palm face up, that's supination. It's like putting soup in your hands. Okay, pronation, palms face down, supination, palm face up. The muscle is called supinator. So the muscle will light up when you turn palms face up. Okay, but the movement is occurring at the proximal radial ulnar joint. That head of radius is radiating in the radial notch. So that's what I want you to see there. Is the ulna moving? No. So radius radiates and the ulna basically is stationary. Another rule to remember when we get to muscles, any muscle that has an attachment on the radius can affect pronation supination. If a muscle attaches to the ulna, it cannot affect pronation supination at all. Because it's the radius that moves, not the ulna. Alright, so know that. So we got head of radius, got the radial tuberosity. Let's take a look at that. So what's highlighted in green, it's a bump. Doesn't really look very bumpy here, but let me zoom in a little bit. It's a big bump on the proximal medial aspect of this bone. It's the radial tuberosity. It's one of the insertions of the biceps brachii. Radial tuberosity, biceps brachii inserts. Right above the radial tuberosity is the neck of the radius, highlighted in green. It's almost a perfect cylinder. You can call it neck of radius or radial neck, either one. A perfect cylinder. And so So it's that old pattern. He goes head, then neck, right? And I should have listed the neck before the tuberosity because it comes next if you're going from proximal to distal, but that's okay. Let's move on to what's next. There's a couple of things distally. Let's see here. To answer the question if it's left or right, in terms of identifying left radius, right radius, notice how the radial tuberosity is facing medially. The front part of the bone, if you look, always look down here, it's really smooth in the front. Okay? So if you can tell medial and front, you'll be able to tell left or right. Because the front is kind of smooth and curves in. And if you look at the back, it kind of is bumpy in the back. Okay, so I'm just trying to give you a hint. How can I tell if it's left or right? If you can tell the front, you're off to a good start. And I think the proximal from distal is quite obvious. The head is proximal. In terms of surface features, down here, you have a little notch called the ulnar notch of the radius. Highlighted in green there. So that little notch is called the ulnar notch, so you should deduce what goes there. Something of the ulna. So you have the ulnar notch of the radius. This notch receives head of ulna, forming the distal radial ulnar joint. Receives head of ulna, forming distal radial ulnar joint. So I'll put it back in the full body mode so you can just kind of see how the head of ulna just fits in that notch quite nicely. So you had a styloid process of the ulna. You also have a styloid process of the radius. There's the radial styloid process highlighted in green. It's lateral. Radial styloid process. It's lateral in the anatomical position, not to be confused with the ulnar styloid process. Let's put it back in the full body mode. Notice that the styloid processes, there's one on each side, and yeah, they tend to fracture. If you fall on your hand and you fracture your wrist, those are some of the things that can fracture. In terms of the next bones I'm going to talk about, the wrist, you can have two of the carpal bones actually articulate with the radius. So what I'm looking at here is, if you're missing it, so this is the front view, the anterior view. If you look at the bottom end of the distal end, that green surface articulates with the lunate bone of the wrist, and that surface articulates with the scaphoid bone of the wrist. So let's think about the wrist, the carpal bones. And I'll just select carpal bones, and you'll see them all highlighted here. And this is the wrist region. So think of them as just 8 small bones fitted together like so. And if I explode them, 8 small bones that you have to know the names of. How I would study them is in an articulated hand. Over there we got a box of hands. And study the palmar aspect. Of course there's the dorsal aspect. I'll just make your life a little easier and test you only on the palmar aspect of the wrist. Okay. I'm going to highlight one bone. I always start with the scaphoid bone. Scaphoid means shaped like a boat. Carpal bones, there's 8 of them. Think of them as 2 rows of 4 to help you learn them. You go scaphoid. Lunate. Triquetrum. Pisiform. Second row of 4, trapezium. Trapezoid. Capitate. Hamate. The hamate has one useful surface feature, that is the hook of the hamate. And I always look for that on the palmar aspect in its medial. So once I get that, I see the hamate, and I see the hook, and I put it medial. I always well, let me show you what I mean. I'm just gonna randomly grab a hand, and I don't know if it's the right or the left. But if you know your bones in the hand, it's easy. Oh, that's the thumb. Okay, thumb on the. Okay, that's my. Okay, there it is. Oh, there's the hook. That's on the palmar aspect. So, oh, okay. That's my left hand. Okay, then I can start naming them. Scaphoid, you know, just like I just named them, writing them on the board. So let me point to here. Scaphoid, lunate, triquetrum, pisiform, trapezium, trapezoid, capitate, hamate. And it'll take some time. The first row of 4, second row of 4. The bones are named for kind of how they appear, but just drill each other in lab until you've got it down. But what I had said was the distal end of the radius pretty much articulates with the scaphoid and the lunate. Okay, and there's a lot of other connective tissues that bind all the other bones together in the wrist, but moving on. From wrist to the bones of the palm of your hand are the metacarpals, and I have highlighted metacarpal 1. Metacarpal 1 is on the thumb side. It's not your thumb. A lot of students think these are your finger bones. They're not. They're the bones of the palm of your hand. They're not your digits. Okay. And in anatomy, anatomists, they still love those Roman numerals, so you got to use them. Metacarpal bones. 1, 2, 3, 4, 5. So they're easy to name. There are 5 of them. They're called miniature long bones, which is an oxymoron. There's how can you be long and miniature at the same time? But anyways, I see what they mean. They're shaped like that, but they're very small, so they are miniature long bones. Well, anyways, what do I have highlighted? Identify bone. Metacarpal 2, right? Isn't that easy? Okay, what's this one? Metacarpal 5. And don't put 5, put V, right? The anatomy, Roman numeral thing. Yeah, I like that. I don't like the regular counting numbers, although I wish they were the regular counting numbers. 1, 2, 3, 4, 5. And the same thing for the bones of the hand. They're called phalanges. Singular phalanx. You have digits 1 through 5, Roman numerals again. And so let me just write the words down. Phalanges is plural, phalanx singular. So what I have highlighted is the proximal phalanx of digit 1. Thumb is 1. Okay. And the anatomy word for thumb is pollex. Pollex is digit 1. So digit 1 has a proximal and a distal, proximal and distal phalanges. However, digits 2 through 5 have proximal, middle, distal phalanges. Proximal, middle, distal phalange, sorry, middle. So I have that bone highlighted. Again, that's proximal phalanx, digit 1. What's highlighted there? How would you name it? Middle phalanx of digit 4, right? And what about that one? Well, that's a proximal phalanx of digit 5. So how I always do this is, to orient myself, I gotta find the thumb. Thumb is 1. Okay. What digit's this? 2. This is the number 1 sign, right? We're number 1, but it's digit 2. Okay, so don't confuse that. I always orient myself. If I can find the thumb, then I'm gold. Let me go to the other hand. Okay, so boom, what's that? Middle phalanx, what digit? 3. Okay, so that's not hard. You shouldn't miss that, I think. That's one of the easier questions in terms of the anatomy bones. All right, we're finished with bones of the upper limb. We'll have a lab quiz on Wednesday. It will be the same format as the last one. Remember your groups? Group A first. Group A first, 7:30, Group B to follow. Only come in when I call your group. I think I had 8 fill-ins. We'll just keep it the same. Any questions on the lab quiz on Wednesday? We'll take our break. When we come back, you have all lab time, because I expect everyone to ace that lab quiz on Wednesday. All right.